Which of the following compounds have the highest boiling point? All right, I'm going to give everyone 2 seconds to decide your answer and we'll continue along with the video. All right, so the correct answer is B, number 2. Now, when we look at the problem, we can see that B is the only one with hydrogen bonding, right? So over here, molecule number 3, that is an ether. So we'll label this one ether. And then on the right, number 4, this is a primary alkyl halide. Perfect. And number 1 is just a regular carbon bond. All right. So when we are talking about boiling point, we are talking about protic versus aprotic, running out of room here, molecules. So protic is water loving, whereas aprotic is water hating. And so you can remember protic because it kind of sounds like polar. So in this problem, only our primary alcohol is protic because it has that hydrogen bond. Now, when we look at other compounds such as isobutylene and acetone, it kind of gives us a little bit of a different story. All right, so on the left we have isobutylene and on the right we have acetone. I want you to think about which ones are protic or aprotic and which one will have the higher boiling point and why, so please pause the video. All right, let's get into it. So acetone is polar, but it is aprotic. My bad, everyone. Polar aprotic. Now, it is that because it lacks the hydrogen bond to an electronegative atom, like oxygen or nitrogen or fluorine for our 3 hydrogen bonds. But it does have, would you look at that? More electropositive here, more electronegative up here. So that is going to give us a bit of a dipole. All right, so what does this mean? And one over here is non-polar aprotic, by the way. All right, nothing special about isobutylene. So because of that electronegativity difference on the right here, what we are going to be experiencing is a higher melting point and a higher boiling point. Now that is going to be around -94 degrees Celsius and 56.3 degrees Celsius, whereas on the left over here, we are going to be experiencing lower melting point and lower boiling points, all right? And so that's going to be about -140 degrees Celsius and -7 degrees Celsius. So to help you visualize what is going on here. All right, next I want to talk about London dispersion forces. All right, I have my 3 carbon bonds here, and I want you to think about which one is going to have the highest boiling point. So you have about until right now. So the molecule with our highest boiling point is going to be right over here. Highest boiling point. And our lowest one is going to be down here. Lowest boiling point. Now, you may be wondering why that is. And that is because the molecule on the left has less carbons to form London dispersion bonds with, or just regular sigma bonds. But it is a smaller molecule, so it is going to boil at a much lower temperature. And if you're wondering, this molecule boils at, I believe, below 0 degrees Celsius, whereas the one on the right is boiling at least over 30 or 50 at least over. All right, now what if I'm showing you a carbon chain? Let's say 2,2-dimethylpropane. Let me show you. Here, let's get rid of this molecule. And let me select the color. Show you. This molecule. And I will also show you this one right here. Perfect. All right. Out of these 2 molecules, I want you to think about which one is going to have the lower boiling point or the higher boiling point. Now, they both have the same amount of carbon bonds, but the one on the bottom is going to have the higher boiling point. And the one on the top is going to have a lower boiling point. That boiling point is going to be about 10 degrees Celsius. And the one on the bottom is going to be about 28 degrees Celsius. Ooh, ugly degree sign. Now, that is because the lower surface area means less interaction with other molecules. The lower the surface area means the less interaction with other molecules. So less hydrogen bonding, let's say. Not hydrogen bonding, but the hydrogens are not going to be interacting with many other molecules. Let's say if it was interacting with an alcohol or water molecule. So you want lower surface area for a lower boiling point. Now let's just note that here. Lower surface area equals lower boiling point. All right, we're getting a little crowded here. Now, let's move on to something else I wanted to address, which is our alkyl halides. So I'm going to have to pick a spot here. Let's say we have a whole bunch of different alkyl halides. We have fluorine. We have chlorine. We have bromine. And we have iodine. Right? I want you guys to think really hard about what you know about these molecules and boiling points, and which one you think is going to have the highest boiling point and which one might have the lowest one. And I'll give you a hint, it's not electronegativity difference. Alright, so now that you have your list of which ones you think are the highest and the lowest, let's go through it. Fluorine, hold on. Fluorine over here is going to have the lowest boiling point, and iodine is going to have the highest boiling point. Why is that? Iodine is a bigger molecule than fluorine. So the bigger the alkyl halide, the higher the boiling point. Alright, so now you can get a clear look at that. And the last thing I wanted to address was our primary, second degree, and tertiary. So let's say you're dealing with an amide or an amine, for example. So here's our primary. Well, I guess I could just do NH2. Let's save some space. And then we have our N over here. Alright, I want you guys to think really quickly which one is going to have the highest BP and which one's going to have the lowest BP. Alright, you guessed right. I knew it. I knew you could do it. Our primary is going to have the highest boiling point. And the order for boiling points goes first degree, second degree, and then third degree. So one on the right, lowest boiling point, and I forgot the P over here. Alright, I hope you guys found this very helpful. Well, you can't really see the bottom corner, but that's okay. Okay, now you can see it. Or I'll cutting it out. Okay, hope you guys enjoyed the video.